Hey class. Today's video is going to look at covalent bonds and Lewis dot structures and how they intermingle. First up, we have to find out what elements create or form covalent bonds. And we know that to be non-metals. Only non-metals. So if there's a metal, can't form covalent. Has to be ionic. So real quickly, let's run through these. Hydrogen and chlorine, will that form a covalent bond? Hydrogen is the only exception. It's the only element on the left-hand side of the table that will form a covalent bond. So yes. What about calcium and chlorine? Calcium, it's a metal. Nitrogen and bromine, both nonmetals, so yes. Phosphorus and fluorine, same thing, both nonmetals. Aluminum and iodine. Aluminum's technically on the right side, but it's still in that group 3, and it's considered a metal, so no. Carbon and chlorine, both nonmetals, yes. Nitrogen, oxygen, same thing. Sulfur, bromine, both nonmetals. Tellurium and fluorine, may not be familiar with tellurium, but it is a nonmetal. Potassium and fluorine, nope. Carbon and radon, it's a tricky one. What is radon? It's a nonmetal, but it's a noble gas. Do noble gases react? No. Phosphorus and fluorine, yes. Aluminum and tellurium, no, we saw aluminum earlier. Rubidium and oxygen, rubidium's a metal. Hydrogen and oxygen, obviously 99% of our bodies are made of these two elements in the form of a covalent bond called water. So make sure you can look at elements and tell, okay, it's going to form a bond or it won't form a bond covalently. Now let's look at the Lewis dot structures to further this explanation. We're going to use Lewis dot structures, or sometimes called electron dot diagrams, and we're going to draw the bond that exists between these two elements. The first example is hydrogen and chlorine. Now you're going to want to have your periodic table handy, and the first step, find out how many valence electrons this particular element has, and then how many it needs to have a full outer shell. So what I do is above hydrogen, I write 1 for how many it has, and then 1 for how many it needs. Chlorine has 7, and it needs 1. They both need 1. If they share 1 with each other, they're going to be happy. So we've got hydrogen, and we're going to make him the filled in circles. So he's got 1 valence electron, and then chlorine's got 7. So we've got 1, 2, 3, 4, 5, 6, and then that one is going to be our 7th electron. But you see, if chlorine shares one with hydrogen, hydrogen shares one with chlorine, now hydrogen's got 2, have a full shell. Chlorine's got 8, which is a full shell. That's exactly what they want. Easy single bond. And the way we can represent that without having to draw all these dots is a straight line. Hydrogen, chlorine. Hydrochloric acid is what that is. If we were naming it, it'd just be hydrogen monochloride. All right, let's look at the next example. Carbon and chlorine. We just had chlorine, so we can fill its numbers in. 7, 1. Carbon's got 4, and it needs 4. If carbon needs to share 4 and chlorine can only share 1, how many chlorines are going to be? It's going to be 4. So let's put carbon in the center and draw his 4 electrons. 1, 2, 3, 4. And now we're going to have a chlorine on each side. Chlorine here, here, and here. And now we're going to draw chlorine's 7 valence electrons. I'm going to use X's this time. 1. So each chlorine has 7 valence electrons. It's sharing one with the carbon, and the carbon is sharing all 4 of its valence electrons with 1 chlorine per electron. And now you can see they all have 8 valence electrons, or a full valence shell. The shorthand saves you a whole lot of time on this. Same setup, carbon in the center, 1, 2, 3, 4 single bonds. To chlorine. This will be carbon tetrachloride. Okay, let's step it up a little bit. Let's go to nitrogen and bromine. Nitrogen has 5, so it needs 3. Bromine's in the halogen family, so it has 7, just needs 1. You need 3 here, you can only share 1, you're going to have 3 bromines. So nitrogen, and then we're going to have 3 bromines around it. And then 1, 2. There's nitrogen's 5 valence electrons. Bromine has 7. Seven, 7, 7. Each one is sharing 1 with the nitrogen, which gives all of them 8 electrons associated. But remember, you have to have this lone pair, or this unshared pair, because nitrogen has 5 electrons in its valence shell, but it only needs to share 3. So it's going to have 2 that don't get shared, or else it wouldn't have a full valence shell. Shorthand for this: I bet you're getting the hang of it. 3 single bonds, don't forget those unshared electrons. Phosphorus and sulfur. How many valence electrons does phosphorus have? It's got 5. It needs to share 3. Sulfur is in group 6. It needs to share 2. That's kind of an odd number. 3 and 2, it works on a totally different scale, and we're not worried about that for this class. So we're going to skip forward, keeping it simple. That's what 2020 is about. All right, last couple here. Hydrogen and oxygen. We know that forms a bond. Hydrogen has 1, needs 1. Oxygen has 6, needs 2. Hydrogen can only contribute 1. There's going to have to be 2 hydrogens for every oxygen. Oxygen's going to be right here. And then we're going to put our hydrogens at a kind of an angle, and we'll see why next unit when we talk about molecular shapes. So hydrogen right there, right there. Hydrogen can only share 1 electron. So we're going to put X, X. Oxygen needs to share 2, but it's got 6 total. So we've got 1 electron being shared with each hydrogen. So hydrogens are good, but oxygen still needs 4 more, so it's going to have 2. This one had 1 unshared pair. This is going to have 2 unshared pairs. Like that. And the fact that these electrons up here are a little bit stronger than the ones that are shared is what pushes those hydrogens down. We'll get into that later. This is called H2O, or dihydrogen monoxide. But we commonly refer to it as what? Water. Shorthand for this, O, H, H, single bond, and then don't forget those unshared pairs. All right, last one. Oxygen to oxygen. This forms a diatomic element, diatomic molecule, because oxygen is one of our diatomic elements. Oxygen to oxygen, obviously they're going to be right here. Each one has 6 and needs 2. So if we're going to share 2, there's going to technically be 2 electrons from this one, 2 electrons from this one in the center. That's going to be what we call a double bond. So I'm going to draw this oxygen here. That's him with his 6 electrons. I'm going to draw this one. With his 6 electrons. So now we've got 2, 4, 6. That's good. 2, 4, 6. That's good. We're sharing 2 each. So if you count the total, 2, 4, 6, 8. 2, 4, 6, 8. All is bueno. The shorthand way to represent that, if one line represents 1 bond, 2 lines going to represent 2 bonds, or a double bond. But don't forget, each one of these lines is 2 electrons. So each bond is 2 electrons. So right here we'd have 4 electrons, which we saw in the long way to do it. I hope this clarifies any kind of misconceptions you have and helps you move forward in the modules. If you have any questions, be sure to let me know. This kind of stuff can kind of be confusing, especially if it's your first time.